The following content is supported by victoris.org.
So today we'll be learning about functions. Lesson 3. Do you see question 1? SpongeBob SquarePants. Okay, so if you are ready, you can read the instructions on the right. And sorry, the instructions not appearing for me. Okay, so wait, the instructions are not appearing for me. Do you mind letting me see? Okay, so when you press run, it says 9, and that's all. Yeah, so that's all the further. You just define your own function. So let's go to Q2. So now in the Q2, instead of just printing the result to the screen, I want to return. Okay? Yep, that's okay. Return, you usually need a space between return and the value you're returning. Yeah, the brackets is just optional. So we run it, you see nothing happen, right? No output. So this says step 3 is propose a fix to see the output of the function. Yep. Okay, awesome. So now we see 9 appear. Okay, there's something to note. I see you have defined, so the parameter as the variable name x, right? And then over here you declare a variable called x and you print x. So it's okay. This is okay. It works. So this is actually it's fine. It's actually working. It works just perfectly. But something to note. This is touching on the topic called variable. Oops. This touching on a topic called variable scoping, where you're saying this variable x, right, is different from this variable x. This variable x only lives within the function, whereas this x is called the global variable. So this is a topic on variable scoping. We won't go too much into detail. Just note that they have different values. Yeah, they're different variables actually. Even though they have the same name, but they're actually different variables because their scopes are different. Yeah. But we won't go too much on that. Just something to note. Okay, if not, then let's go to Q3. Okay, so in this question, right, I've written a template for you, right? Define a Pythagoras function, and I want you to write the code inside here that implements the calculation of the Pythagoras theorem. So Pythagoras theorem, you have two sides of lengths a and b. Then the third one will be square root of a squared plus b squared, right? So it's your job to fill in the code over here. And what assert is basically saying, so remember conditionals, right? This entire thing is actually a conditional, right? Pythagoras 3, 4 equals to 5 is conditional. This assert is saying, if let's say over here I wrote something, just as I say return 1. Then when I run it, you see what's it gonna say? It's gonna say line 5, right? Assertion error. What that tells me is that line 5, so Pythagoras 3 and 4, what does it return? In this code, what does Pythagoras 3 and 4 return? No, not quite. Remember the code over here? It called the function a and b, and we just return. In my current implementation of Pythagoras, it should return 5. That's the correct answer. I mean, that would be if I implemented the Pythagoras function correctly. But in this case, I just write a faulty Pythagoras function just returns 1. So what's the value when I call Pythagoras 3 and 4?
1.
Yeah, correct. So it says 1. So now Pythagoras 1 equals 5. That's false, right? It's a false conditional. Assert false, it tells me assertion error. So this assertion, when I have assert a conditional, it makes sure that the conditional inside here is true. If the conditional inside here is false, then it's going to throw an assertion error. So if I return 5 over here, you see that now line 5 is the assertion error. But if I return 5, it's going to pass this assertion because 5 equals to 5, right? But in this line, 5 equals 13 is a false. It's a false value. It's a false conditional. So it fails. So you see line 6 now. It says line 6 is error. So it's your job over here to implement the correct Pythagoras function to ensure that all these assertions pass. Make sense? Are you confused? Yeah. So you need to write code over here that passes all these tests. And as soon as you see that there's no assertion error, then you know your code is correct. So this is one way I can test your function. Okay, so if you're a bit confused, let's discuss a bit, okay? So I tell you to write a function that takes in two positive numbers a and b. In this case, it's over here. right? And make the function return the length of the correct answer. The length of the hypotenuse of the right triangle. So by Pythagoras theorem, right? What is the answer in math? Okay, remember our previous multiply function took in two parameters, a and b, and returned a times b, right? Yeah, so in this case, it takes in two parameters, a and b, 3 and 4, but I want to calculate the Pythagoras theorem of these two numbers. So if let's say so I want Pythagoras 3 and 4 to be 5. How do you obtain 5 from 3 and 4?
Return then put in the formula.
Yeah, that's right.
But then what does the equals 5 mean?
Oh, okay. Maybe if you are okay, if that's confusing, right? I can just say I can comment these parts out, and I just say, basically the equals 5 is just trying to say that. It's just trying to say that if I do print Pythagoras 3 and 4, I want the output to be 5. I want the output to be 5. If I print Pythagoras 5 and 12, I want the output to be 13. Would this make sense?
Also, does the assert just mean if the Pythagoras 3, 4 equals to 5?
Then it'll be okay.
Print 5.
No, it won't print 5. It'll be just you just pass by the code without any errors. Assertion allows us to check the truthfulness of a conditional when the code is running. So like so what I mean is that, let's say we had this over here. So if I write assert true, nothing happens. Assert 1 equals to 1, nothing happens. But if I write assert false, it throws an error. It says assertion error. If I write assert 1 equals to 2, it's assertion error. So the reason I had this code over here, you understand the top part, right? But the reason I had this code over here is I want this basically saying, if your code runs without problems, then all these 4 conditionals are true. Yeah. Okay, yeah, I understand it might be a bit confusing, but you can just take it as this. So just implement the correct Pythagoras function such that there's no errors. Okay, when you're ready, you can try running your code. Okay, you can try. Okay, so you try running. If you try running the code. We're gonna meet some errors, right? So inside the function, it says, so right now x equals Pythagoras. So it calls Pythagoras. It creates a variable called x and assigns it the value of Pythagoras 3 for. What is Pythagoras 3 for? There's no value at the moment, right? Yeah, correct. So you need to change it.
Yeah, what is this?
Okay, so you want the square root of the Pythagoras formula goes by
A square plus b square equals to c square, sorry.
right, c being the
c
answer.
equals to square root a plus s square.
Yeah. Can? Does it make sense? So we want, currently you have the square root in place, right? Now it's calculating square root of a, but that's not quite what the answer we want, right? We want square root of a squared plus b squared. Correct? Make sense? So how do we want square root of a squared plus b squared. So how do we write that in code? Okay, so if we want the square of something, we can write, so let's say a is 2, square of a would be a times a, or you can write a square 2.
Oh.
Yeah. Okay, great. Yeah. So we can try running. Okay, so now you see it works. Now the first 5.0 comes from here. The second 5.0 comes from here. The 13.0 comes from here. Okay, and now you've written the correct functions. So now if I have this, I run. See, there's no output, no errors.
Oh.
It works fine. But if let's say let's say I return the wrong value over here, let's say I do +1, then it's gonna throw me an error saying this one expected 5 assertion error because this was 6 on the left hand side. It was 5. It was a false statement. So these assertions are just here to make sure that your code is correct. Yeah. They are a form of testing your code. In real programming practice, it's very good to always put assertion errors to make sure that like it pass certain checks inside your code. Yeah, even though it doesn't add any functional value, like no practical value, but it's a good check. So if something fails, you know exactly where it failed because your code might be very huge. Okay, yeah. So let's move on to the next question. Okay, so let's write our own function, the absolute function that would help us calculate the absolute value of some number. So you can look at the assertions over here. Absolute of 3 should be 3. Absolute of -1 should be 1. You know, you're aware of the...
Kinda.
Yeah. So can you try writing your code inside here? So this is the first question where we start to see conditionals come into play. So you can have conditionals inside a function. Yep, that's right. So define absolute. The absolute is the name of a function, which is correct. It takes in the parameter x. Okay, so the formula is, so how do you let's think about how we want to implement it. So if x, right, is positive, we are return x, correct? But if x is negative, when return
Positive.
Yes, positive. How do we get from -1 to 1? How do we get from -2 to 2? -3 to 3, -4 to 4. If x has the value of -1, then what is 1?
Is
You want to remove the sign,
Pow.
right? Huh? Pow.
Is it? No.
How do we remove the minus sign from?
You multiply it by a negative.
Correct, exactly. Multiply by -1 is -x, correct? Yeah.
How do you add conditions in this?
Okay, so you can just add conditionals just as you would normally in code. So you have, yeah, that's right, if. Then you need the, yep. So after a conditional, you put a colon, and now the code inside. So if x is negative, right, then how do you remove the minus sign, so called? So return, what value do you want to return? Yep. Yeah, that's right. Else return. Okay. Yep, that's right. And then your line 6 return is not really necessary anymore. Okay, so when you run it, what does it say?
Do I have to say something else first?
Not really. What do you want to say? Oh, okay. So if you run it and there's no errors.
Oh, nothing will happen.
Nothing will happen. If there is an error, then something will happen. Then you'll see a red sign. Is there any output?
No.
No, right? So if I run it, it's just fine.
Something to appear.
You want something to, there's a sanity check, right? So you can try print. Yep.
What?
Yep, you see 6 appear. Good. You also see 6 appear, can? Yeah. So if I put in a negative number, it'll return -1 times a negative number, which just removes the minus sign. If I put in a positive number, it'll return the number itself. If I put in 0, which conditional is it going to be? Is 0 less than 0? No, right?
Else.
It will be the else one, so it will
Mm.
return 0. But it doesn't really matter. You can put, for all you know, you can just put less than equals. It's still the same result because 0 times anything is just 0. Yeah. Okay, so if not, okay, let's go to Q5 where we need to fix some of the errors of some code that I have. So I wrote some code over here and I have some errors. So can you please help me fix it? Okay, so
What is
some of the lines I write. Oh, collage is okay. It's a math thing actually, but you just need to change it such that it doesn't such that the output is correct. So let's do the first question first, okay? Then we go on
Oh,
to that
there's
later.
3 questions.
Yeah.
Okay.
So some of the comments I say don't change this line is because I don't want you to touch this line at all. I don't want you to play cheat and just say print 9 to the screen. Right? Yeah. So you try to run it now. It's gonna say you try to run it now, it's gonna say there's gonna be some error. It says line 3 indentation error at line 3.
Ah.
So can you guess what's wrong?
Hmm.
Correct. So you press run. Okay.
Still wrong.
Now it says line 8 invalid syntax. So now the error has gone from line 3 to line 8 already. Line 3 is fixed, but line 8 is still.
Define.
It's like line 8. So what's wrong in line 8? When you define a function, you have a function name. Yeah, you need a colon. That's right. Okay, let's try to press run.
What does this mean?
Okay, so
okay, never mind.
I'm just telling you, if you put a negative sign into the into the side of the side length, then it's wrong.
Hmm.
When you're ready, you can press run and see whether. Wait, so we see 9 appear. That's good. Now we see line. Okay, let me just remove this. No, actually, let me just put it back. Okay, so line. Now we see line 14. They say Pythagoras is not defined. Didn't I define Pythagoras over here? Yeah, so yeah, that's right. So you need the function name to match exactly word letter for letter. Then now it works. Okay. So lastly for line for the last exercise, I want so you see 9 and 13 appear as output already, right? And I want 2 to appear. How come I see 2 to appear, but why is there this none over here? What's going on? Where does the none come from? Okay, so if I pass 4 into the function, right, 4, n has the value of 4 inside the function, then is 4 mod 2, this percent sign is the remainder. 4 divided by 2 leaves a remainder of 0, right? So, so 0 on the left hand side equals 0 is true. So it executes line 19, which is 4 divided by 2, which is 2. So that's why we see 2 appear on the screen here. Then after that, I take the value, store it in x, print x. Why is x? So the none comes from line 24. But something is a bit funny, right? Because I don't want the none to appear. Can you guess what's wrong? Which are the lines you can edit?
This one, this one, this one.
Yeah. So can you guess where is the error? I see none being printed, but I want to avoid that. I only want 2.0 to appear. Okay, hint, right? Good guess. So these are lines that print stuff to the screen, right? Remember previously I said that when if x equals to something, right? This collapse thing. Currently, why is x none? You see, x is none. It's because we are not exactly, yeah. So when you don't return anything from a function, right, then the value is none.
Okay.
Yeah. You try pressing run. If it works, then okay, great, it works. So usually we put spaces in between return and the value we want to return, but it's okay. So yeah, okay, great. So that actually concludes the exercises for lesson 3. There's some extra, but it's okay. Okay, so something to note, right? So we have learned functions now. now actually functions we have actually touched functions in lesson 1 already. Can you guess where we touch functions? It's actually in the print function. You see, in lesson 1 we write print. You see the round brackets, right? You may be wondering what is the round brackets for. The round brackets was telling when we write x equals to 4 and print x. You see, print is actually a function. It's a function that is built into Python. So we call the function print and we pass in the parameter of the value of the variable x. So print was a function and we pass in some stuff. In fact, print can actually take in more stuff. For example, okay, right now, if I print x, okay, yeah, so print was actually a function lah. So print was actually a function. What other functions were there that we encountered? Remember when we type input, remember when we type input and then inside the round brackets we put the prompt that we want to ask the user for. So for example, type your age, like that. When we have something like that, right? Input itself was actually a function. Then we pass in the string that we want the prompt to be. Okay, so all around us was actually a lot of functions. And then there's also float, right? Remember we converted float. When we write float input something, it was actually converting a string that we pass into. So if I say, it was actually converted a string that we pass into a float. Likewise for integer of 9 in a string, it prints 9. So actually we're dealing with functions all along. Yeah. Okay, so if not, then actually that's it for lesson 3. Good.